Thank you for having me here today. It's been an exciting meeting, and we're very happy to participate here at Clemson. Clemson University in 2013 started the Wood Utilization and Design Institute. It is a joint operation between architecture, construction science, civil engineering, and forestry. So we're all right on campus and working together, and we've been looking at cross-laminated timber. We've been looking at new designs in old methodologies, and we're going to talk a little bit about it today. And I'm even going to borrow from David Fell on some of what I'm going to present today. So why the Southeast? We think it's a great reason to be doing mass timber in the Southeast because we have the resources, we have the growth, and we're starting to do the research, especially in the mass timber. We've been doing it for a while yet already, and I want to talk about those three areas today. So the resources, I'm going to talk about saw timber availability, saw timber pricing, and where are our sawmills, because that's what we're going to start with, and a lot of this mass timber is the wood. Saw timber availability, forest to markets just recently produced this slide in a study that they did, and as you can tell, we've increased our saw timber availability, our saw timber inventory 3.4% annually over the last 7 years. So we have lots of saw timber. And in fact, if I look in South Carolina alone, we have more saw timber than almost any other state in the Southeast. In 1987, there began a program called a Conservation Reserve Program, and a lot of farmers started planting trees. And then in 1989, we had a hurricane that took out a whole year's annual production or an annual harvest in one night. And we replanted those trees, and if you do the math, they're like 20 years old now, or 20-something years old now, and that's what's filling up that. So my state forester likes to say that we have a wall of wood, and it's moving and getting older. And when 2009 hit and people stopped harvesting saw timber for a while because the residential market went to pits, we continued to grow trees. And that's the beauty of South Carolina. We grow trees really well. And so we have a lot of trees. We have over 13 million acres of forest land in our state. About half, just slightly under half, is softwood, and the other half is hardwood. So we have all the traditional southern yellow pine species, and when I refer to a lot of our work, I'll talk about southern yellow pine. So this is that southern yellow pine. And then Forest to Market also came up with these prices recently. This is saw timber stumpage prices, and so you can tell that I think we're sitting there at about $26 per green ton for what we're paying for saw on the stump for the wood. Now we have to take it to the mill, we have to get it processed, but we still have fairly low cost saw timber, and South Carolina would probably be, because we have so much, maybe at the lower end of that, because these are Southwide observations. And then the U.S. Forest Service has put together this. This is data from 2009. They've not put out their latest data that I have found easily. These are all the sawmills. The blue are hardwood, the red are softwood, and the greens are combined hardwood and softwood mills. So we also have a lot of sawmills in our southeastern United States, and South Carolina is right over there in the middle of the East Coast there. We're the pie-shaped state in this group. Now this is more recent data from South Carolina. The green squares are pulp and paper mills. The sawmills are in blue, and they're divided up in terms of large, medium, and small. And you will see that we have a lot of sawmills in our state that are actually quite productive. We also will let you know that we have 3 owners from Canada that are there also. So we also enjoy the benefits of having Canadian owners. We have Canfor, West Fraser, and Interfor here in our own state. So we have sawmills, so if you need wood, we got wood. If you need sawn wood, we got sawn wood. And the growth in the United States, I just want to talk briefly about the Southeast. As you can see from the Census Bureau, The population growth in the southeastern United States in 2000 was at over 30%, and it's continued to grow, and it is the fastest growing population region in the United States. What we've found is that the value of construction that's put in place, I wanted to bring that up to date, and so this is actually from my colleague Al Gertzel at Seneca Creek. And he did this study for us. We were looking at residential versus non-residential. So here are the numbers for the United States in total, the South Atlantic, and then South Carolina as one portion of that. And we're doing a major study on what are the building rates in South Carolina and what could wood take care of, or how much could wood grow. Right now, the forest products industry in our state is one of the largest single industries. It's at $18.6 billion in our state, and we know that we can easily go much higher with the supply of wood we have. So we have plenty of wood to continue this. This gives you the breakdown of the non-residential and public and private. We're especially looking at how can we push public buildings to go more into wood. It's sort of a way of encouraging our government to build with wood. Again, value of the building construction, residential versus non-residential. If you look at the non-residential building, it's about 49% versus 51% for residential. And then when you look at the wood market share, the non-residential, there's only about 12% of the wood market share, and the residential, it's 88%. And I'm so sorry that those words are broken up strangely, but I couldn't figure out how to fix it. So PowerPoint was not my friend the other day. And then non-residential construction framing type in the United States, again, that 12% for wood. What we're looking at is health, hotels, stores, education, and finishing up with recreation offices, religious pieces, industrial, public, and other miscellaneous buildings. This just gives you an idea of where we're building in South Carolina. We are 31% commercial. We are building in all these major areas, and this breaks down how our building systems are going in our state. And almost all of those, wood could be there, and it could grow. So the value of our non-residential construction in our state is about $4.8 billion. It's about the same as residential construction, and it has not recovered as much from pre-recession levels, but it did not decline as much as housing. Our building codes are becoming increasingly more inflexible for the use of wood products, and over 90% of non-residential projects by value are low to mid-rise structures with opportunities to use wood products. But the wood market share in the non-residential construction remains low. In South Carolina alone, wood products consumption in the non-residential market could more than triple if all low to mid-rise buildings were constructed with wood components. Now, our state is actually quite aggressive when it comes to building codes, and we are accepting the 2015 building codes right now. My biggest problem is just getting our architects and our building owners to ask for wood. So my theme for a lot of the times when I'm talking is wood, just ask for it. We got it. It's homegrown. It's local. You get all those wonderful lead points if that's in your piece, if you're in your mind. The carbon is there. Everything works, but we have to get those building owners to ask for it. So one of the things we're having in May is a series of workshops for architects, engineers, and building owners of city, county, and state governments to say, hey, look at what you can do. Why are you buying steel and concrete from out of state and sending our dollars out of state when you could be helping our rural economies and our own state folks who own wood and owns forest land and who produce in our state? And CLT is one really good option for that because, as many of you have heard, we grow southern yellow pine. And some people don't actually like to frame with southern yellow pine. I don't know why, but you know. But when you put southern yellow pine in a CLT, it's beautiful. It's gorgeous. It doesn't bend, it doesn't crook, it doesn't sweep, it doesn't do any of those things. It's strong. It's really strong. And it's a great marketplace. So let me turn now from some of the economics that we're doing and look a little bit more at the research that we've done on mass timber. So we started under a USDA-funded project to see if we could build southern yellow pine out of southern yellow pine CLT. Now, our wood lab was built in the 70s. That was brilliant because we still have pieces of equipment that are sitting there that have not worn out and that can do it, including a Newman press that's 4x4, and not many people have that. So we were able to run in, plane all our wood that was donated by Columns Lumber. Thank you, Scott Brothers, for helping us out with donating all our wood. We then, with the wonderful help of all of the manufacturers that helped us with our glues, including some of the sponsors here today, we were able to put our glues in. And the good thing about being on a college is you got lots of help. So we had a great student project that went on to work on this. And then we did the Newman press. And so we learned how to do it 4x4 at a time, to where we could make 4x8 panels or 4x12 foot panels, and we were able to make all of that we needed. We then took part of our processes that we had done. We did 13 CLT panels of different layout configurations, adhesives types, and with or without the protection of gypboard, and sent them to the Forest Products Lab for fire tests. So some of you may have heard about the Forest Products Lab testing of southern yellow pine about a year and a half ago or 2 years ago. That was actually southern yellow pine CLT that was manufactured in Lahotsky Hall in Clemson, South Carolina, and sent up for those first early studies. So yes, we found out that the traditional long cross long layup had a fairly uniform burn through. The long cross, which we did look at, the layup, we had an uneven char rate that was observed. The fire burned through some of the seams of the parallel lumbers. Now, none of this was finger jointed because, of course, we were able to find, we had 12-foot lumber available, so we didn't have to finger join any of our lumber for this. Here are the types of glues that we used. So we had an MF, a PRF, an EPI, Pure, and I think the Pure is the Pure X. And we looked at some of those, and we looked at the failure mode and what was left of the percent of laminates and things like that. That study is available from the Forest Products Lab if anybody wants to look in depth at it. They have it, and it really does work. Were there differences in glues? Yes. You know, it was a study. You expected to see differences. Does that mean that any of them wouldn't pass? No. We felt like we came out of there in good shape. We did see that the gypsum protection did provide a 2-hour fire rating and made it, for us, a promising candidate for all of the building types that we were thinking of at the time we were doing this. We also have looked at a lot of measurement on our product that we have done and looking at whether we could get the PRG 320 based on what we could measure. And let me tell you that we went from not only the 4x4, 4x8, and 4x12 panels. A big shout out of thanks to Structurelam. They were able to make full-size CLT panels for us, which we then shipped back to South Carolina. And we have continued to test not just on things that we made in our lab, but we've made tests that we've been able to test on manufactured panels of southern yellow pine made by Structurelam and Penticton. So we were able to do our rolling shear test, and don't get me on the engine, because I'm the forester here. I'm telling you what my engineers are telling me. So this is one of the tests that they did. And these are the results, and if you'd like to see them more in depth, we'll be happy to provide that for you. But we were looking at all of those. We looked at bending, so this is one of the bending tests that we did. Another bending test. And our pilot plant panel pressed a 2x6, 12-foot. There's no finger jointed, so some of the Structurelam panels did contain finger joints. I think you can see here in this picture, this is Structurelam. There are finger joints in that one. Now we're working on a long span system. So we have we had a group of engineers that were looking at a hollow core floor system where we put glue lam beams in between CLT panels. There were some opportunities that we thought this would give us more width and openings, and also allow you to move mechanicals hidden away in a floor. So this is one of the things that we've been looking at. And those tests, we had to actually complete the building of a gravity floor, and we have 5 by 40 foot panels ready to go as soon as that gravity floor is scheduled for us. There was someone who got it scheduled ahead of us, so I think it's operational now. They're going to do their test, and within the next month, we'll be doing our test. So yes, we looked at screws. We've looked at acoustic membranes. We've looked at combinations of screws and glues. And so that's some of the things. This is our strong floor that we'll be looking at, and that hole was originally about 6 foot deep, so it's got lots of big steel beams in it, and we'll be able to run our test on that. This is just about completed. Another project that we're looking at, we have a new student who's funded by the National Science Foundation, and he's going to be looking at CLT and tornado-resistant homes. This is some of the ideas that he's looking at. And yes, we have had a lot of fun shooting our cannon at 4 by 4 panels that we were made. We fired 4 shots between 70 and 100 miles per hour one afternoon when we were out there. This is about shots 1 and 2. You can see in there just a dimple. Hopefully you can see that. That shot 3, we went up to 75 miles per hour. And unfortunately, at 100 miles per hour, it stuck. So we actually put a hole in the CLT at 100 miles per hour. But it was late. It was late in the afternoon. We're going to go back. We're going to redo this test. We're going to make sure that the technician who was running that cannon really knew what he was doing, because it sure looked like it was faster than 100 miles per hour to me. I think he sharpened the point on the 2 by 4 also. But again, this is our proposed research study to continue to work on this process, because we think it has some capabilities. I do want to mention a non-mass timber project that we've worked on. We've developed a Simply structural system. We did this with plywood. All of this is CNC cut. And this house, we've built 2 already, one on campus and one at the U.S. Solar Decathlon this year. There are no nails in this house. There are screws and there are a few bolts, but there are no nails in this house. It's held together with stainless steel zip ties. It was built by a crew working 2 shifts a day at the Solar Decathlon, 1,000 square feet, 3 bedrooms, in 8.5 days. It's a remarkable feat, but it has a very unique system of fastening that our engineers feel could be applied to larger mass timber. So some of the technology that we're learning in how to put a house together without nails and without a lot of power tools and without cutting, we talked about compartment, doing things off-site. Everything in this house was brought to the site, and the only hand tool we needed was a screwdriver. So everything was done off-site and brought in, and so it came in an 18-wheel flat pack kind of assembly and turned into a home. So it was very unique, and we really are continuing to do research on that. So we think that will go into, eventually the Simply fastening system will be used in mass timber. The other project that we have funded right now is funded by the U.S. Sea Grant. And this Sea Grant program is to look at scale model testing of large balconies that are possible because of CLT. We're using both horizontal projections and vertical projections that divide the units. So this is our model made out of glass. And we actually, if you'll see the white sections on those are 3D printed sections that have sensors in them to allow us to sense exactly what's going on in the wind tunnel. These are those 3D printed panels that allow us to collect wind pressure data on the projection faces. And previously, we were unable to measure this location accurately. So that was one of the pieces that we were able to do, is develop this technology. And then here is the proposed hotel with balconies sitting in our wind tunnel, and our wind tunnel is capable of reproducing atmospheric boundary layer measurements on wind and to test this. So prior to our wind tunnel studies, prior wind tunnel studies had provided a depth of experience for us. Our wind tunnel is used for both research and outside consulting work. And so if anybody's interested in having some tests done in a wind tunnel, we've got it. This is an example, this picture is an example of where a group of buildings were out there, and they were going to add another building, and they wanted to see what happened to the area with the new building in place, so they asked us to model that for them. Next, we'll take that same concept funded by Sea Grant, and we'll be looking at water intrusion, and we'll focus on CLT-specific water barriers and cladding systems, and we'll be doing that research at it's an insurance facility. It's in Rock Hill, South Carolina, where you can actually put your panels in there and throw rain and wind at it and at very high levels. And that lab is run by a former Clemson professor, and he's going to be able to let us get it in there. So that's our next piece. I would like to thank our graduate students who are in engineering, Eric Gu, Michael Stoner, Bill Ashman, and our former graduate student, Graham Montgomery, who has done all of the work so far on CLT for us. We're continuing to finish up our work, and all of these are either, well, most of them are master students on to PhD students. So we'll be graduating, well, Graham's already graduated, but the other three will be graduating with their PhDs, and they are believers in the beauty of CLT. I'd also like to mention that there is other research going on in the Southeast to do with CLT, and my colleagues at Virginia Tech provided this information for me. They've done mechanical strength and stiffness work. They've done some fire testing work, and they've done some acoustical testing work. And Dan, I don't know, Dan, are you here? Dan's in the back. If you got any questions about this work, talk to Dan, and thank you, Dan, for providing these slides. And this is done in cooperation between Virginia Tech and the Southern Virginia Higher Education Center. And then also, Virginia Tech continues to work on the mechanical properties of yellow poplar. That's not yellow pine, but yellow poplar CLT. And for those of us who are really CLT junkies, we really loved the American Hardwood Export Council's building of the stairways modeled after Eicher's famous painting. And these are Dan's colleagues and collaborators on all of his projects. So I think, and I'd like to acknowledge all of our collaborators and funders and all of the people behind us. There's a large group of them that are out there supporting us in our work, and we keep looking for more research dollars and opportunities to do innovative research. I will also say that we've had graduate studios in CLT. We did our first graduate studio in CLT in 2013, and we produced about 35 master's level architects that had the pleasure of designing a housing facility for graduate students on our campus. They had 5 locations to choose from, so we came up with there were 2 students to a team. There were about 15 different teams that learned how to think about CLT and mass timber and design and build with it. We look forward to more studios. Our solar decathlon studio is the one that did the development for our Solar D. But for almost the last 6 years, Clemson has maintained at least 1 wood studio in our architecture program ongoing every semester. So it's very hard to finish an architecture at Clemson University, which is one of the best architecture universities in the world. And we are in the top 10, I think, in the U.S. at least. But they've almost all got an experience or a taste or a feel for working in a studio that does wood. And we also are very dedicated to design build, so we like to have things where they actually get a feel for wood and they actually build with it. And we think that makes them appreciate it more, because it's one thing to look at wood on the screen of a computer when you're a student and you're trying to pick materials. It's a whole nother thing when you touch it. It's a whole nother thing when you realize what a difference there is between a birch plywood and a pine plywood. And it's a very tactile experience, and our kids really seem to love experiential learning, and they really have enjoyed, I think, getting their hands on this product, because wood is just not wood. It's not just a thing. It's very different from species to species. It's very different from product to product. And I think it's something that our students really need to get their hands on. And we also do a lot of integrated projects where we have our engineers working directly with almost every one of our studios in architecture, so that we're collaboratively learning and understanding the whole system together. Thank you very much for having me here, and we'd love to see all of you in South Carolina talking about mass timber next year.